Today we are going to tackle a fascinating math problem that has sparked curiosity among many mathematicians. What is the infinity root of infinity? We know that radicals are equivalent to fractional exponents. For example, if you take square root of x, we can write in terms of fractional exponent, that is x raised to the power 1 over 2. Similarly, this infinity root of infinity, we can write it as infinity raised to the power of 1 over infinity. But infinity whole raised to the power of 1 over infinity is an indeterminate form. That means it is not well defined. However, by looking as the limit extends to infinity, so here we are taking x tends to infinity, then x whole raised to the power of 1 over x. Here we can gain insight into the behavior of infinity raised to the power of 1 over infinity. Limits helps us to understand how a function behaves as the input approaches to a certain value. That's why we are substituting x raised to the power of 1 over x to understand the properties of limit raised to the power of 1 over infinity. Now, let's take a closer look at the expression x raised to the power of 1 over x. Suppose if you take x as 1, that means 1 root of 1. So we can write this as 1 raised to the power of 1 over 1. The value is 1. If you take x as 2 root of 2, we can write this as 2 raised to the power of 1 over 2. The value is 1.414. And keep on you go. If you take x as 100 root of 100, this we can write it as 100 raised to the power of 1 over 100. The value is 1.047. If we keep on go and take infinity root of infinity, the value is approaches to 1. As you can see, as x approaches to infinity, our result approaches to 1. But we cannot just assume that that is true. We need to prove it mathematically. Now observe here, limit x tends to infinity, x raised to the power of 1 over x. Our x is in the exponent form also. Whenever x is in the exponent, we have to use logarithm. This is easiest way to solve for x. So that's why I am taking here natural log. Suppose if we have a, this we can write it in terms of natural log, that is e raised to the power of ln a. Here exponential e and natural log are opposite function. After cancelling we will get only a. That's why instead of a we can write it as e raised to the power of ln a. Same like that. Here also limit x tends to infinity, x raised to the power of 1 over x. We can write this as e raised to the power of ln limit x tends to infinity, x raised to the power of 1 over x. Now observe only the exponent form, which we have ln limit x tends to infinity, x raised to the power of 1 over x. Let's observe only this. This we can write it as limit x tends to infinity, ln of x raised to the power of 1 over x, isn't it? Now this ln x whole raised to the power of 1 over x, it is in the form of ln of a power m. So according to the logarithm property, we can write this as m times ln a. Similarly, this we can write it as limit x tends to infinity, 1 over x, it looks like a m. So that's why we can write m times, that is 1 over x times ln x. So this we can write it as limit x tends to infinity, ln x over x. Now substitute x as a infinity in here. So that is ln infinity over infinity. ln infinity, the value is infinity only. So infinity divided by infinity, that is undefined. Whenever the function is indeterminate, you have to apply the L'Hospital rule and re-evaluate the limit. So that's why I am applying L'Hospital rule here. So what is the L'Hospital rule? Limit x tends to some constant. If we have a f of x over g of x, then we can write it as limit x tends to this constant, derivative of f of x over derivative of g of x. So now apply this L'Hospital rule in our function. What we have, limit x tends to infinity, ln x over x. Limit x tends to infinity, derivative of ln x over derivative of x. We know that derivative of ln x, the value is 1 over x. So let's write 1 over x over Derivative of x, the value is 1. So now what we have, 1 over x over 1, which is 1 over x only. So limit x tends to infinity, 1 over x. Now substitute x as infinity. So that is equal to 1 over infinity. The value is 0. Limit x tends to infinity, x raised to power 1 over x. So the value is 0. So let's substitute here. So that is equal to e raised to power of, this value is 0. So e raised to power of 0, the value is 1. That's it. Thanks for watching and don't forget to subscribe for more math content.